Irrational numbers, not talking about rational like being able to be reasoned with, rational like ratio. A rational number can be expressed as a fraction. And a rational number can be a terminating decimal, so that it could be just an integer like 8 or 1.2, and there's no more decimals after that, or a longer decimal that doesn't continue. Still, in the terms of rational numbers, numbers that can be expressed as a fraction, which is a kind of a ratio, we can have recurring decimals. So a recurring decimal like this, 0.5 with a dot above it, is 0.555 forever. Same with this one. That's negative 1.444444. This one has 2 point, and then the 3, 4, 5 pattern actually continues. So we're still, all of these are real numbers, right? And they're our imaginary numbers, but don't get me started. So a rational number, you can write it as a fraction, it's going to work. An irrational number, it can't be written as a fraction. No dice, you can't do it. The square root of 2 is going to go on infinitely. It's not going to happen. Pi is 3.14159 something something, and it goes on forever. It infinitely goes on and on and on with new numbers. This, I would say phi in American English, or what's often called the golden ratio. That is approximately 1.618033, but it goes on forever and it doesn't repeat. So these are what we would call irrational numbers. You can't write them as a ratio. So let's just talk about fractions again. Equivalent fractions will equal each other. 2 over 3 equals 6 over 9, because if I multiply both of these, or divide if I was going in the opposite direction, by the same number, I'm going to get an equivalent fraction. It's the same way, it's a way of expressing the same thing. Improper fractions is when A, if we're looking at A over B, is greater than B. So we'll use the approximation of pi, 22 over 7. That's an improper fraction, where a proper fraction is where A will be less than B. So I'll use that same example and flip it over. That's a proper fraction. Fraction can be simplified, dividing the numerator, both the numerator and denominator, by the highest common factor. So if I wanted to simplify 6 over 9, I would divide them both by their highest factor that they have in common, which I'm going to tell you is 3. Just trust me on this one. And now I've got a simplified fraction. A mixed number is when we have a whole number, I'll guess 3, and then a proper, can't be improper, a proper fraction. 3 2/3. Now you can't really compare fractions unless you have a common denominator. So I'm often asked, which is bigger, 1/3 or 1/4? Well, what I'd have to do is find a common denominator. So if I look at the lowest common multiple of both of these, if I do the multiples of 3, 3 times 1 is 3. Let's just write it out. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. Hello. 4 times 1, 4 times 2, 4 times 3. That means I'm going to have the equivalent of 1/3 with a 12 on the bottom, or the equivalent of 1/4 with a 12 on the bottom. 3 times 4 is 12. So 1 times 4, I get 4 12s. And 4 times 3 is 12, and 1 times 3. So look, lo and behold, I can tell you categorically, because we're using a common denominator, that it actually, which one is bigger? 1/3 is bigger or greater than 1/4, but I can only prove it with a common denominator. If we've got a recurring decimal pattern, a dot or bar is used. So if we had, say, 0.16666, and it goes on forever, the most accurate way to write that is 0.16 with a dot, because that is true. Whereas if I just did this, I don't really know what it means. But we'd use a bar. You can use dots, but I'll show you how to use the bar. If we had, for example, 0.27 and the 27 repeats, so that'll be 0.27 with a line over it. Okay, let's look at some more, let's look at some practical examples. So write these fractions as decimal. So if you have 3 3/8, I'm just going to ignore the 3 because it's going to be at the front of our decimal. We want to figure out what 3/8 is. This is what you're going to do. You're going to punch this into your calculator. 3 divided by 8. Okay? Because that is what that means. That vinculus means divide by. So you can use long division to figure this out, but if 3 over 8 is 3 divided by 8, and that's going to give us 0.375, did it say? So that is a rational number, as you can see. But remember, we need to keep count of that 3. So we reserve the 3. So 3 and 3/8, write it this way, is equal to keeping that 3, and the 3/8 is represented by 3.375. Same thing, 5 over 3 is the equivalent of, or is to say the action of 5 divided by 13. So we don't have a whole number to deal with this time. So we're just going to divide 5 by 13. Let's do the ABC this time. 5 ABC 13 is exactly the same thing, equals 5 remainder 13. Hit the ABC button one more time, and that gives us the decimal. Now look what's happening here. If I actually played this whole thing out, you would see that 384,615, it continues, but it's not showing me the whole picture. I promise you that it will continue to go 384,615, 384,615. So that is equal to 384,615 recurring, because that 384,615 is just going to go on and on and on and on. Now, to do the opposite of that, we have to take a decimal and write it as a fraction. So our decimal is 0.24. We look at what this is called. This is tenths, hundredths. So we have 24 hundredths. And then we just do with our equivalent fractions what we did before. And let's see, we can divide each of these by 4, which gives us 6. Divide this by 4, and that gets us 25. I don't think we have any more common denominators there that we can go and reduce it by, so there's our answer. Now, this one is 2.385. So we were in the hundredths this time. Again, we're going to reserve the 2, and we're going to do 385 over 1,000. Why is it 1,000? Because you have tenths, hundredths, thousands. It's all about place value again. So we're going to take that, and we're going to reduce it. Let's see, let's divide by 5. If we divide each of these by 5, so we're going to get 77 over 200. So therefore, we keep track of that 2 that we left behind. 2 and 77 over 200, and that's the best that we can do. Now, again, if we're going to decide which one of these is the larger fraction, we need a common denominator, so we can't get away without it. So I think we're going to look for our lowest common multiple for our denominator. We've got 12 and we've got 15. So let's see, if we multiply them, I'm going to find that my lowest common multiple is, for these denominators, is 60. Just trust me on this one. You can work it out. So it's going to be 60 or 60. So again, multiplying 12 times, what is it, 5? We'll do the same with 7 times 5 is 35. And 15 to get to 60 is multiplying just by 4, isn't it? So 8 times 4 is 32. Therefore, 7 over 12, the equivalent of 35 over 60, is greater than 8 over 15, which is equivalent of 32 over 60.